In simplifying radicals, we want to first simplify all the radicals before we can actually do anything to combine them together. I'm going to simplify first. So what that means is, if I'm looking at number 1, I'm going to break down what's inside the radicals into factors that are either perfect squares or perfect cubes or perfect fourths, whatever the whatever root we're looking for. So 27 is 9 times 3, and 9 is a perfect square. And 12 is 4 times 3, and 4 is a perfect square. So we take out the perfect squares. Square root of 9 is 3. And the square root of 3 stays under. Square root of 4 is 2. And the square root of 3 stays under. And then we simplify by multiplying the things that are on the outside. So that's the first step. We have to make sure that our radicals have the same index and the same radicand. That really kind of makes them like terms, if we think about it algebraically. So, since these are both square roots of 3, we can combine them to, we can just do the 9 minus 4, which is 5, square roots of 3. And there we just kind of did that. So let's look at number 2. Number 2, we're looking for cube roots, so we need to look for perfect cubes that go into these numbers. So 54 is 27 times 2. 2 does not have a perfect cube. And 16 is negative 8 times 2. So we take out the things that are perfect cubes. Leave what's not a perfect cube underneath the radical. And simplify those. Then once we have everything, and this problem is cube roots of 2, so I'm just going to take 9 minus 2, which is 7. 7 minus 14 is negative 7, cube root of 2. Let's look at number 3. Be careful because we have cube roots and we have fourth roots here. So simplify what's underneath the radical into perfect fourth roots in this case. So that's 16 times 3. There's no fourth root in 3. And then 72 is 8 times 9. 8's a perfect square, 9 is not. Okay, or perfect cube. So now I simplify them. I'm looking for the fourth root of 16. That's 2. The fourth root of 3 doesn't simplify. And then the cube root of 8 is 2, so this is 3 times 2, cube root of 9. So this is 14, fourth root of 3 minus 2, fourth root of 3 plus 6, cube root of 9. Combine the like terms together, so 14 minus 2 would be 12, fourth root of 3, and then this one is all by itself. But that is the simplified form. So we just keep practicing that. 28 We want perfect squares, factors for 28. 4 goes into 28. Perfect cube factors in 56. Since it's negative 56, we'll make the perfect cube negative. And then square roots, factors, perfect square factors of 175. That's 25 times 7. Then we simplify them. So 10 times 2, square root 7. And if you can go right to this step here, that's fine. Some days I can and some days I can't. So I take out the perfect cube of negative 8 is negative 2. We're left with a cube root of 7. And then take out the perfect, or the square root of 25. So I have minus 2 cube root of 7 minus 20 square root of 7. The like terms are going to be the things that are exactly the same. The square roots of 7. So we end up with 20 root 7 minus 20 root 7 cancels each other out. And we're just left with this negative 2 cube root of 7. The cube root of 7 and the square root of 7 are not like terms. So try number 5. When you get to the point at the end where you are combining your like terms, your variables and your roots have to be the same. And in this case they are, so 7 minus 3 is 4, and then you have x squared y square root of 2. You should pause the video and do number 6. Make sure you understand it. Once you get to this point, you should notice that this exponent and this exponent are not the same. So you do not actually have like terms. So negative 2a squared cube root of 5a plus 6a cubed, cube root of 5a. Even though the cube roots of 5a are the same, the variables in front are not. So that's our final answer. So that's the adding and subtracting. Now let's look at the product. So when we are multiplying, we're going to use the whole product rule, that if I think of this as exponents, I am taking the same root but multiplying a times b underneath the radical. So if they're the same root, I can just put them under the radical and multiply, and then we simplify it. So these are both square root, so I would rewrite this as 27 times 5, and the square root of, let's see, 27 times 5 is 135. Then you want to break that down into perfect square factors. So that is 9 times 15. Incidentally, that could also be broken down like this. But then I just take out what's the perfect square and leave what's not a perfect square inside. If you've got numbers on the outside, you're just going to multiply those numbers first. So I have negative 6 times 10 times 18. So negative 6 root 180. Look for perfect squares that go into 180. I think 36 is the largest perfect square that goes in there, so that's 36 times 5. So take out 6, and we get negative 36 square root 5 as our final answer. There is no cube root of 9, so that doesn't simplify, but we're just combining them together, so multiply the things on the outside together. And then we have the same radical, so we're multiplying 9 times negative 24. Simplify that to 2 cube root of negative 216. And negative 216 is a perfect cube, so this is 10 times negative 6, which is negative 60. Okay, so now we're looking for fourth roots. So we have negative 3 times negative 1. And then we have fourth root of 64 times 8. So that makes this 3 times the fourth root of 64 times 8 is 512. Then break that up into factors that are perfect fourths. So that's 256 times 2. So this is a perfect fourth. Three times 4 is 12, times the fourth root of 2 would be our final answer. So now we look at situations that have variables in them. And we do those the same way. So you multiply whatever's on the outside together and whatever's on the inside together, so it's 6 times 8, and then add those exponents. So we would have 5 times the square root of 48, x to the 9th. And then simplify 48 into perfect squares. So 5, let's see, 16 times 3. Then x to the 8th times x. Take out your perfect squares and leave the rest underneath the square root. And then simplify. So 5 times 4 is 20. X to the 4th times the square root of 3x. Give number 12 a shot, pause the video, try and do that one on your own, and then you can check it. Hopefully you did well on that one. So I'm just going to work through these. You can practice these. Pause the video and check, see if you did them right, or you can follow along. Okay, now when we're multiplying, this is the distributive property. So you're going to multiply the square root of 10 by both of those terms. So that's the whole term here. So I'm going to have 5 times the square root of 5 times 10 minus 2 times the square root of 2 times 10. I would simplify those first, and then look at taking the perfect square factors out. So square root of 50 is 25 times 2. Square root of 20 is 4 times 5. So square root of 25 is 5, so this comes out as 5 times 5. So it's the square root of 2. 4 is a perfect square, so that's 2 times the square root of 5. Simplify. And notice that we have square root of 2 and square root of 5, which are not the same, so that means we are done in that step. So if you are looking at number 16, this is the double distributive property, so we have to multiply the 8 times the 3, that's 24, then 8 times the square root of negative 10, or negative square root of 10, so that's minus 8 root 10, then minus 3 root 10, and a negative times a negative is a positive square root of 100. Now simplify this. The square roots of 10 don't simplify, so I'm just going to simplify this one here and then combine my like terms together. So 24 plus 10 is 34, and then these guys are like terms. So negative 8 minus 3 is negative 11 square root of 10. So 17, again, you're going to multiply the firsts. So I have 6 times the square root of 36 plus 6 root 2 minus 6 root 12 minus 6 root 4. Simplify what we can. So 36 is a perfect square. That one does not simplify. 12 has a perfect square factor. And 4 has a perfect square factor, so that's really 6 times 2. So I have 36 plus 6 square root 2 minus, take out the 4 times 2, so that's minus 12 square root 3 minus 12. Did I do something wrong here? Oh, I did. This one right here is 6 root 12. So hopefully you fix that. Well, then I can just see that these are the same. Then I could have probably canceled it up there. But these cancel, so 36 minus 12 is 24. So remember that this 4 times the square root of 5, the whole quantity squared, means that I am writing it out and I have to multiply each part. So this is not just squaring those terms that are inside. So we have 4 times 4, which is 16, times minus 4 root 5, minus another 4 root 5, plus the square root of 25. So that is 16 minus 8 square root 5 plus 5, which is 21 minus 8 square root 5. So what happens if we have variables? Well, we just follow those same rules. So that's the distributive property. So this is going to be the square root of 36k squared, because you're adding those exponents. Then the 2's on the outside here. 3 times 15 is 45. K times k squared is k cubed. So simplify what you can. Square root of 36k squared is 6k. But 45 is not a perfect square, so I'm going to write that as 9 times 5, because 9 is a perfect square. And then k cubed is k squared times k. So I take out what I can and leave what I don't have underneath the square root. And I multiplied that one wrong. That should be a 3. And as tempting as it might be to cancel these guys out, that 5K, that square root of 5K makes it not like terms. So this is actually our answer. All right, so you should try and do number 20. Pause the video and try and do that one on your own. I hope you did well on that. Now let's look at 21. They've given us a nice picture here. It wants you to find the area and the perimeter. So the area means that we are multiplying, and perimeter is that we're adding all the sides. So let's do the area first. So we're going to multiply 4 minus square root of 6 times 7 square root 6 plus the square root of 3. Right, okay. So that is 28 root 6 plus 4 root 3 minus 7 root 36 minus the square root of 18. Simplify what you can. So 18 is 9 times 2, so I'm just going to leave that as 3 square root 2. Then combine your like terms together. You don't have any like terms, actually. So we just write this out. 28 root 6 plus 4 root 3 minus 42 minus 3 root 2. So that is the area. Now to find the perimeter, remember that perimeter means we're going to add up all the sides. So that basically means that you have 2 of each one. So I have 2 times 4 minus the square root of 6 plus 2 times 7 root 6 plus the square root of 3. So distribute. 8 minus 2 root 6 plus 14 root 6 plus 2 root 3. Nothing simplifies, so you combine your like terms. You get 8 plus 12 square root of 6 plus 2 square root of 3. And that is it. So you should be able to, it's a 1-page homework. I was expecting it to be 2. It's only 12 questions. Make sure you show your work. If you need more space, you should be able to do it on the back. I think the back's blank. If you need to put another piece of paper in there, you can go ahead and do that. I'll be able to answer questions tomorrow in class.